Welcome everyone to the Geekvape Seminar Leap Further. I'm David, your host, and I'm joined by my guests. Welcome to the show.
Thank you.
How are you guys?
Doing very well, thanks.
You're very well. So John, can you introduce yourself to our public?
Absolutely. My name is John Dunn. I'm the Director General of the UK Vaping Industry Association. It's great to be here today.
Thank you, John. Thomas?
So I'm Thomas from Germany. I'm a content creator on YouTube. Yeah. And I'm doing content for years, I think since 2015 now on YouTube. Yeah.
Thank you, Thomas. Poti, welcome to the show.
Hi, David.
So, Poti, can you introduce yourself real quick?
Hi, guys. I'm Poti, Marketing Director from Geekvape. I'm so excited to be here with One Shoot Media and you guys.
Thank you. We're excited to have you on. And we're going to go straight to the first topic then. No, vaping is not a simple thing. We experience some problems from time to time, leaks, dry hits, whatever, speedbacks. And we went in the streets of Paris to ask vapers some questions about the problems they may encounter in vaping. And that's right now.
Oui, j'ai eu pas mal de matos avec des problèmes de fuite de liquide. J'avoue qu'à un moment, ça m'a un peu découragée. Je cherchais les matos les plus simples, sans fuite, et je suis partie à un moment sur des systèmes à cartouches, juste à cartouches jetables. Et finalement, ça me coûtait trop cher. Et maintenant, je trouve que ça va un peu mieux. Je trouve que le matériel fuit un peu moins qu'au début.
Oui, ça arrive souvent.
Ouais, j'ai déjà eu du matériel vraiment très débutant que j'avais pas très bien choisi peut-être. Et donc oui, pas mal de fuites. C'était surtout au début où je vapais, où c'était pas très régulier. Je savais pas comment me servir de ce matos. Mais oui, j'ai eu pas mal de fuites. Ouais.
Alors oui, on a de temps en temps des retours de clients qui se plaignent de fuites du coup, mais c'est vraiment de moins en moins fréquent.
Ouais, une fois, alors c'était un peu malgré moi, parce que le liquide qui avait fuité, du coup, a foutu en l'air mon accu. Du coup, ma vape était inutilisable pendant plusieurs mois.
Mais oui, ça aurait pu être un argument pour que je pense j'arrête la vape. Heureusement, j'ai tenu bon.
Alors, si vraiment il y a le fabricant qui garantit un système sans fuite, oui, ça peut être un argument de vente.
Oui, tout à fait. Donc pour moi, la qualité, c'est sujet premier, quoi, en fait.
Ouais, pour moi, c'est un super argument de vente.
Carrément, je veux dire, je pense que c'est le truc qui énerve un peu tout le monde quand on a un setup, surtout. Enfin, moi, il traîne toujours dans mon sac à main. J'avoue que ça m'énerve toujours un peu d'avoir des fuites. Donc, si un matériel me promet de ne jamais fuir, j'avoue que ce serait un bon argument de vente.
Je suis pilote d'avion et donc en altitude, ça avec moins de pression, et sur ça, j'ai choisi un autre matériel.
Alors, oui, il est déjà arrivé que des clients justement plus arrêtent la cigarette électronique parce qu'ils ne rendent pas vraiment la machine ou rien, mais clairement, on les revoit cloper à la rue. Ouais.
Okay, it seems leakage is a big problem in vaping. Mm-hmm. What is, according to you, the main reason for leakage?
I think the main reason is the structure of the design. So nowadays, leaking problem has been greatly improved on the products among the leading brand. The use of some technology has effectively avoided the leaking problem. So, for example, Geekvape, we use LSR, a high-precision liquid silicon rubber, which has a good sealing performance and high temperature resistance.
That's the silicone you use in the tanks, yeah?
Yes, silicon you use in the tank.
All right. So you make sure to use the proper materials to avoid this kind of problems.
Some precision materials and some precision producing process.
Yeah,
so
okay.
Make it leak proof.
Okay. So leakage, big problem for vapors, as we saw. Thomas, according to you,
Yeah.
leakage, is it the main problem in vaping?
I'm not sure about that, but I think it's a big problem. Yeah, because people use RDAs. So I know there's a big problem with RDAs when they build themselves. But I think it's on devices like this a problem with sub-ohm. There's a problem with leaking, I think, that people use the wrong juices. So, yeah. So I think there is a problem, yeah. And we have to fix it.
How do we fix it then? That's the $1 million question.
Yeah.
Because leaking in vaping, I mean, it's omnipresent.
Yeah.
Even for experienced vapors, we all experience it. So I think Geekvape, you would have an answer.
The use of some technology, just like the silicon liquid rubber and some precision produce technology using own products, especially the leading brands. So I think we are progress.
Yeah.
Yeah.
It's
still
less than it used to be, but
yes,
it's still there.
it's still there.
John?
I think for me, it's all about, the user experience, as we said, but I think this is where vape shops really come in to their own, because I think, technology can only take you so far, but people understanding how to correctly use the device is really important too.
Yeah.
And I think that's where, specialty vape shops versus convenience stores or small stores really are really important for that.
Down to education rather
Absolutely,
than
yeah.
just the hardware, just how to use it.
Exactly.
Yeah, it's also true. Even though I know how to use my hardware, I like to think I know that, but I still experience leaks from time to time. Obviously, leaks are problematic in vaping, but it's mostly, to me, down to airflows anyway, because most of the time the airflow is at the bottom, and that's where the liquids come out. So it's an age-old debate: top airflow, bottom airflow. Well, amongst the geeks of vaping, it's a debate anyway. Thomas, according to you, what are the pros and cons of each system, the top airflow versus bottom airflow?
I think I don't know who was the first one with top airflow. Was it? I think that was Geekvape, eh?
Yes, I think.
Yeah. I
From
think
the
they
juice
brought
tank.
the first, yeah.
Yeah, top airflow,
Top
bottom
airflow.
coil.
I think when they start with top airflow, they had problems with the flavor, with the taste. So it works, but not that well. The bottom airflow works, but today I think they did a perfect job on the top airflow. And when I have the choice, I would prefer the top airflow, because the biggest benefit of that is, that it can't leak on the bottom side, and that's why I make the decision for me to use a device like this with a top airflow.
So that's the criteria for you to choose
I think
an atomizer.
Yeah.
The airflow at the top is.
When I have the choice
choice.
between two devices, I would take the device with top airflow.
Okay, John.
I'm in the same
Your
camp.
disposables.
No, but I'm in the same camp. I've always had trouble with bottom flow, because obviously the liquid is sitting on top. Anything that can go wrong is going to go wrong.
Yeah.
So for me, having it at the top is just less likely for issues to develop.
Especially when you take a plane.
Absolutely.
I mean, that's the main reason, huh?
Yeah. So I think we used to think bottom airflow is better than top airflow, because from somebody's point of view, the airflow will through the bottom to the air, so it can cover all the heating part. So I think the airflow has a better performance and more even. But since a top airflow tank comes up in the market, so it gets a better performance in leak proof, and also it has a good heating performance as well. So I think many brands join into airflow side.
The top
airflow side.
The top airflow movement.
Yes.
Do you think everyone is going to join that? That you just said.
I think it depends on users' hobbies. It depends, just like what Thomas said.
I think when you have the choice,
It's a choice.
It does make the tanks a bit bigger.
It's
more complicated to
This
implement.
is one part of the negative points, because you need the room for the airflow goes down, so it makes the tank a little bit smaller, or the tank bigger, the volume a little bit smaller. So, but I think people can live with that, and that device is a good example that it can work well. Yeah, I think we are on the good way to building
The
top
perfect
air flag.
atomizer, yeah.
Yeah.
We'll talk about that later in the future of vaping for everything that should be perfect in vaping.
Yeah.
And I can't wait to hear your answers on that. We will now join the Geekvape lab for their experiment on airflow, and their results are very interesting. They compared the top airflow and the bottom airflow and did all kinds of physics simulation. I let the geeks talk for now. Over to you at Shenzhen Lab.
Hi David, hello everyone. I'm Ivy and this is Dr. Zhang and engineer Bo Yang from Geekvape Research Institute.
Hello everyone, I'm Dr. Zhang from Geekvape Research Institute and welcome to the Geekvape Laboratory.
Dr. Zhang, we really look forward to today's experiment. Could you please introduce this simulation test?
Yes, so basically we are using CAE tools to simulate the vaping process. CAE stands for Computer Aided Engineering. So that means we are reproducing the vaping process in the computer. And based on the information we obtained, we could compare the details of these two kinds of atomizers.
Okay, so shall we get started?
Yes. Okay, so let me introduce first what kind of atomizer we are using. So the first one is the Geekvape E100. That's the top airflow design. So we see the air inlet here on the top. And for comparison, we are using the bottom airflow structure. So basically, the air inlet is located on the bottom.
Okay.
So, I think it's very important to mention that for the simulation, we are using real life parameters. For example, the airflow volume, we set it as 18 milliliter per second. That's basically the volume we inhale by the lungs. So that's just one example. So we are simulating it with real life parameters. So I just want to emphasize that. Okay, so the calculation consists of 3 steps. So the first one is to generate 3D models in the computer. So Bo Yang is going to show us how these models look like. So, okay, we see here 2 3D models. On the left-hand side, that's the top airflow structure, which is this one, E100. And on the right-hand side, that's the bottom airflow structure, basically this one. Okay, so now we have the 3D models. The next step is to set up the parameters. For this, we have some file. So basically, all the important parameters are listed here. And we have preset them already. So now we just show it, but it's done already, the setup.
Okay.
So the next step is to run the calculation. So for that, we would open a calculation environment. So now Bo Yang is going to input the code and the calculation will start. So let's see how it works. Okay, now it's initiated and it will start very soon. Let's see. Okay, now the calculation is running.
What's this calculation for? I mean, what result will we see?
Yes. So for this calculation, we are going to compare the air pressure of these 2 atomizers. So the distribution of air pressure.
Okay.
We will see the results now.
Okay.
So Bo Yang, could you open the files for the results? Yes. So it takes some time.
So the first calculation, is it for the top airflow or for the bottom airflow? The calculation that Bo Yang just
That's for the top airflow.
Okay.
So okay, it takes some time because the result is located somewhere in the computer. Okay, so this is the top airflow. So we see the distribution of air pressure, and the different colors represent different value of the air pressure. Okay, so now the first calculation is done, and we will run the calculation for the bottom airflow. Okay. So Boyan, please go back to the parameter settings. So again, these are the parameters for calculating the bottom airflow structure. So now we will go to the
Calculation environment.
yes, yeah, we call. You are very smart.
Thanks.
And now we will run the calculation.
This is for the bottom airflow.
Yeah, now it's
right?
for the bottom airflow. Yeah, we need to modify the code a little bit.
Sure.
Bottom,
Good things
you see
need
the
to
bottom.
wait.
Okay, now it's initiated but now it's running.
Wow, looks so cool.
Yeah, it's a lot of computational steps. Okay, now it's done. So now Boyan will show us the results of the bottom airflow. Yes, okay, this is the bottom airflow. We see the air flows like this. So now let's compare the results together. Okay, we see that based on the color or the value of the air pressure, these two structures are basically very similar. So we say that the distribution of the air pressure has no big difference between these two structures.
Okay, so when it comes to vaping experience, I mean, what the air pressures have on the the vaping experience effect?
Yes, we usually say that the air pressure is strongly correlated with two effects. The first one is the air resistance. The second one is the, let's say, the smoothness of vaping. So if the air pressure is similar, so the air resistance and the smoothness, they will be similar. So we have, with both structures, we could have the same nice vaping experience.
Okay, I see. I think we can move on to the next calculation. I was wondering what's the thermal efficiency will be look like. So can we move on?
Yes. So for the thermal efficiency, again, we will use the same 3D models. Yes, 3D models, and for that we will have the same parameters. Of course, I call it same, but it's the same looking, but the details would be different. And then we would go to the environment to do the calculation. But usually this kind of calculation would take a very long time. So to save time, we have done the calculation already.
Oh,
and
really?
so we have prepared the results here to show the difference, also the similarity. Here is the animation of the top airflow mode. So we see how the temperature changes with time. So, and we have the next animation, which is the bottom airflow. Again, we see how temperature changes with time. Of course, we don't get much information just from the animations. So, to make it more clear, we prepared two figures. Boyan, please. Yes, okay. This is the first figure. So that's how the temperature changes with the cycling time. Here we see 3 cycles, and then we see how the temperature changes in each cycle. So that's for the top airflow, and we prepared the same figure for the bottom airflow. We see 3 cycles and how the temperature changes. So based on these data, we can calculate the thermal efficiency. So yes, so these are the equations for calculating the thermal efficiency, and so they are complicated, but the results are straightforward.
Yeah.
So we see that here. This axis is the thermal efficiency in percentage, and these are the circles. So, okay, we see that the blue column, the top airflow, the blue column is higher, slightly higher than the red column, the bottom airflow. So that means, so top airflow structure has higher thermal efficiency than the bottom airflow structure.
So, what does that have any influence on the vaping experience? I mean, will it has a better vaporization effect?
Yes.
The higher one.
Yes, because of the higher thermal efficiency.
Yeah.
So the vaping temperature in the atomization zone is slightly higher. So that would give us two positive effects. The first one is that the flavor would be fuller, so it's better flavor. And secondly, so the cloud would be bigger. So the amount of e-liquid that has been vaporized would be higher.
Okay, I see. But I'm also curious that will the vaping experience be better if the the temperature is higher? Because I'm a bit worried if the temperature is too high, it might hurt our lips, right?
Yeah. That's really a big concern.
Yeah.
But we did the computation. Also, we did the measurement. So in the real life situation, and we have found that the temperature of the cloud is somewhere between 40 and 50 degrees C. So we believe that this temperature range would not cause damage to our mouth. So it must be safe.
That's a great relief. And here comes another question. You know, the oil leakage problem has always been a huge concern among all users. So I was wondering if that has something to do with, the structure
Yes.
design. So
Yes.
could you please tell us the difference between the top and the bottom airflow structures?
And for that, of course, we have also done the calculation. And we have prepared two animations. The first one here is the top airflow.
Maybe we can use this analyzer to show the audience.
So we see that, okay, this here, the bottom part of the of this atomizer is completely closed.
Yes.
So that means if the e-liquid flows out of the atomization zone, they will be deposited on the bottom, but they will not come out of the atomization.
Yes.
So that's why we don't have this leakage problem. And on the contrary, so if we look at the bottom airflow structure, so if the e-liquid comes out of the atomization zone, it will flow directly out of the atomizer because of the air inlet on the bottom. So that's a big difference, and that's why the top airflow should prevent the leakage problem.
Okay, thank you. I think the audience understand now. So thank you, Dr. Zhang, for your explanation, and also Boyan for your detailed operations. And I think we're done here. So thank you guys for watching this, and thanks, David. And I think we're all good here. So maybe you should say goodbye.
Bye.
Bye, everyone.
So as we saw in this video, not a whole lot of difference between top and bottom airflow, apart from thermal efficiency and a whole lot of geeky stuff and less leaks, obviously. Thomas, are you surprised by these results that we saw?
It's good that they have the same results, because that means that you can choose the top airflow and you have the result people like with the bottom airflow. So I think that's a good way now. So yeah, I don't know. I'm not surprised, but it's great. So
I was kind of surprised by this, especially with the airflow dynamics. About that, I would have guessed that the dynamics would be less efficient in the top airflow because the air has to travel such a complicated path. But
in
apparently
the
it
end,
doesn't.
in the end, it comes on the same points.
Yeah.
So I don't know.
Yeah, well, you know, that was
I'm not
just
that geeky.
Yeah, it's very geeky stuff.
I'm just a user. So, and for me, it's important the result, and the result is it's good. So,
sure,
that's all about.
That's all about efficiency at the end.
Yeah.
Poti?
For me, I just want to show that result. Let people know what happened in a tank, what airflow goes out in a tank, and what tanks work. So just focus on the user experience. I do not want to say which one is better, but I think the user experience is the most important.
Okay, that's the first time I've seen that actual studies on airflows and all that. Is great. It's good for vaping advancement anyway.
Yes, of course.
This kind of simulation, I really like that. I'm not sure everybody does, but I do. Are you a geeky guy or?
Not really, but I think what I got from the video was that from the thermal efficiency, it's almost like a preheating of the liquid. So to me, that is almost like a notch above. But they're so very, very close. I think, as we said, it comes down to personal choice, I think.
Yeah. So in the end, really, it's the leaks and a little bit of more efficiency overall in the system, which is, to be very simple, you get more vape out of your batteries. Slightly more, not a whole lot, but slightly more. Well, thank you guys for this very interesting and geeky points. You guys, we're really down to the geeks now. I understand the name Geekvape now.
Thank you.
It's really interesting anyway. We looked at the atomizer. Now we shall look at the chipset and the batteries, which is very important as well. They really drive our vape. And we are going to talk about that with our guest right now. Thomas, when you buy a device, you told me already that you like the top airflow, but when you buy a device, do you really pay attention to the chipset that it contains or the kind of batteries that it carries?
Yes. Yes. I do.
A selling point for you?
But I'm not the right person for that question because I have many devices at home for years, and I'm not sure about that. When it's hard to think in a normal customer.
Yeah.
So
because you get so many devices to test every day.
Yeah.
But should you buy one? Would it be an important matter for you?
Yes, but I'm not sure how it is when I have no experience or no knowledge about that. So I have this, so it's hard for me to get in this thoughts.
Yeah.
You know what I mean?
Okay.
So, but yes, it's very important for me as a professional vapor. Yeah. And I think they're getting better now because I tried this device and I complained about that they didn't use a 21/7 battery, but I think they have with the regular batteries really a long lifespan here, or capacity in the device. So that's great. So
it's quite an efficient chipset. I was surprised myself. But then again, I use
I vaped yesterday,
proper good batteries as well.
And when I went to the hotel, the battery was still full. So
and you vape at?
Huh?
How many watts do you vape?
55. 55. So
quite a strong vape. Poti, you like blowing clouds as well?
Yes, because I want to be a rich man.
Yeah.
I want to make a big crowd.
That's your heritage, right?
Yes, of course.
Okay. Tom?
Yeah, for me, I think the chipsets are great. The simplicity setting for me is a real benefit because, as we said earlier on, not everybody is a geek, right? Not everybody is understands all of the watts and the settings and things like that. So for a consumer who wants a powerful device and an efficient device, having that simple setting is great. And I think also with the battery, the more efficient we can make these batteries, the better. They're smaller, they're more efficient, they last longer. Because let's face it, we have a planet that we need to take care of. Lithium-ion batteries are extremely expensive now.
Yeah.
So the more performance we can get out of less materials, the better it is.
Yeah, and especially in vaping, you don't want your device dying on you when you just quit smoking.
Exactly. Well, it's like an iPhone or
Yeah.
a cell phone. You get halfway through the day and it dies. You don't want to have to go plug it in. You know?
Sure, sure.
Yeah, many points on a device that's important for the people out there because, the battery has to last long. So you need pass-through so that you don't buy a second device to carry with you. And that's it. And another good point is here what I said before, the smart mode. Yeah, I think that's a good function in a device. People don't care about the resistance on the coil. They just stick it on or screw it on and they can start vape and don't have to think about what wattage I have to use now. So
you don't even have to look on the
Yeah.
resistance. What is the more efficient wattage
Yeah.
you already have?
this is
The smart mode inside.
that's good, yeah.
I'm pretty sure you spend a lot of time talking about chipset and functions and functionalities. How is it? How do you choose whether to add or take off a function inside the chipset? Is it from customer feedback? Is it from your clients?
I think most requirements is from customer requirements. We do a lot of marketing research from our consumers, and we're trying to improve our devices' performance, trying to provide the best experience to our users. And I would like to mention that vape is not only tank. You can just focus on the tank. So the tank also is very important because it provides the best flavor. But we also need to care about the chip and the battery. Some people just care about the capacity of battery, the performance of the chips because it is easy to feel, right? And I would say actually that battery and the chips also will affect the stable flavor. That's why we prepare another test to show it.
Yeah, we're going to see that right now. And that's another very geeky test now about chipsets and batteries. Over to you.
Hi, David. Hello, everyone. I'm Charles, product line executive from Geekvape. Let's see you guys again. And this is our test manager, Mr. Bai. Welcome to the test center of Geekvape. Thank you for the questions. Today, we will answer them through two experiments. As we will know, the output voltage plays an important role in optimization. It will directly affect the accuracy of the liquid optimization. Simply to say, the delicacy of the flavor. So the value and the stability of the output voltage are pretty important. This time, we will show you how we figure out the output power of our products. We will test the output voltage among different products under the same coil resistance. From Ohm's law, I is equal to U divided by R, P is equal to U times I. We can easily know that P is the square of U divided by R. After we have the value of the voltage and the resistance, we can get exact value of output power of a product. Okay, let's start the test. I got two products in my hand. Both of the two products are fully charged. This one is our new product, Aegis Booster 2. This is a product from the market. Both of the products are up to 60 watts, built-in battery, fully charged. We are going to simulate the practical application environment of these two products. Let's have a look at output voltage on the oscilloscope. So Mr. Bai will test it. First one is Aegis Booster 2, fully charged, 60 watts, and 0.2 ohm resistant node. The output voltage is 3.5. After calculation, we get it. The real output power is 61.25. Let's come to the second one. This product is from the market. It's also fully charged, built-in battery up to 60 watts. Let's see the performance under 0.2 ohm resistance node. We could see from the screen the output voltage is 3.39. So we are calculating the real output power. The real power is 57.80. We could say the output power between the products when they are fully charged is really similar to each other. But let's say how they perform when they are around 40% battery life. They are still using the same resistance, 0.22 ohm node. This bar is working hard, guys. So the real output voltage of Aegis Booster 2 when it is 40% battery life is 3.45. After calculation, the real output power is 59.85. After this, let's come to the other product from the market. So this product is also 40% battery life under 0.2 ohm resistance node. Right now, we could see from the screen the real output voltage is 2.98. After calculation, the real output power is 44.40. So this is the first test for the two products.
Thomas, we were talking off air about the upstepper, downstepper.
Yeah.
Do you mind to elaborate on that?
Yeah, I just asked a question about how they raise the voltage. So with an upstepper now. So I ask how much voltage I can get out of this device, and you say around about 6 volts, eh?
Around 6 volt, maybe 5.8.
Yeah,
5.8 volt, even in a low battery.
Yeah, and then you can you have an upstepper in this device and a downstepper.
Yes. We have up and down steps, which can provide the best performance, even the battery in a very low level.
Yeah. Because that's important when we talk about the efficiency of a chipset. Sorry, is that it could be efficient when the battery is fully charged, but as soon as the battery goes down, and it's the way with the batteries, they discharge over the day, then the chipset doesn't perform as well, which is what we saw in this test. I never thought to do that. in all my review time. I never thought to actually measure the performance of the chipset with the battery sag. And it's very interesting. Very interesting results.
It's very interesting. Yeah, because it will affect the flavor. It will provide a stable flavor. So, and I mean, I want to say it's very important, but people doesn't know that before.
Yeah, you can, so on some chipsets, you can actually feel the battery going down and the power going down. With this, it's rather constant.
Yes.
That's quite a lot to ask for a single 18650, 100 watts. It's quite a lot. I remember back in the days, it was 20, 30 watts maximum, and now it's 100. Is it down to the quality of the batteries, or is it down to the R&D that went into creating the chipsets?
Well, both of them. Both of them. It's down to the battery capacity and also the chips as well.
Okay.
Yeah, because I think vaping is kind of like a system, not simple technology, not simple function.
Yeah. Okay. So it's two evolution combined into one to make it happen, to make it possible.
Yes.
Yeah. All right. Thank you. I have one for you, John.
Go for it.
Do you take care of your batteries?
You should always take care of your batteries. I don't know how many interviews I've done.
But do you?
Of course, they need to be inspected regularly. They need to be changed regularly.
Yeah.
And when you're out with them, put them in a bloody case.
Yeah, that's important.
Very, very much so.
Because most of the time, the accidents that are reported about vaping, it's just down to the battery.
Absolutely, and people don't understand that, and I deal with the press quite a lot. So over a number of years, I've had many interviews on exploding batteries. But the nice thing is they're getting less and less now. So I think people are starting to get smart. Yeah,
they're starting to carry batteries around more often. I'm seeing on the news that batteries are something to be, a force to be reckoned with.
Absolutely, don't throw them in your pocket with your keys.
Yeah, that's a bad idea. Don't do that, please. We have a second video, I think, from the Geekvape lab about another experiment again. So we're going to see that right now, and then we're going to talk about that.
Now, let's start our second test. I got two products in my hand. On my left hand is the new product HC Eternal. On my right hand is the product from the market. Both of these two products are external battery, up to 100 watts. This time, we will use a top-tier 18650 battery, same as the one used on our new energy vehicles to do an extreme test. Here is a preview. The built-in version of Eternal adopts the same battery, and it will be released soon. Let's have a brief view of these two products. Both of them are up to 100 watt and are fully charged, and now we will connect them to a 0.2 ohm node to simulate the practical application environment when they output at the max level. Let's have a look at the value on the oscilloscope. Mr. Bai, please. So first, it comes to the HC Eternal. It is using the fully charged high-quality 18650 battery. Under the 0.2 ohm resistance node. Let's say the real out voltage from the screen is 4.48. After calculation, we got the real output power is 100 watt. Let's come to the product from the market. It's also up to 100 watt, external battery, Mr. Bai is putting the same battery in the product. It is using the same 0.2 ohm resistance node. Let's see how is the performance. We could see from the screen the real output voltage is 4.61. After the neutral mass, we get the real output power is 106 watts. So we could say there is no obvious difference between them when they are fully charged. But let's say how they perform when they are around 20% battery life. They are still using the same resistance, 0.2 ohm. First comes to the AGC internal. So we could get it. The real output voltage for AGC internal when it is 20% battery life is 3.44. After the calculation, we got it. The real output power 59.16. We switched the battery to the other product. So we could say the product from market is using the same battery under the same coil resistance 0.2. We got the real output voltage is 2.67. The real output power is 35.72. So let's come to say the whiteboard. When they are fully charged, the two products are very similar to each other. When it is around 20% battery life, AGC internal is much powerful than the product from the market. Okay guys, this is our second test.
And we're back. That was eye-opening, this efficiency test with the battery side. We just talked about it, but seeing it in measures, it's quite impressive to arrive at such a result. Were you surprised by this?
So I'm really surprised because we didn't know what is going to happen before the test.
Yeah. Did you do the measure twice? Because it seems wild, the difference between the two performance.
Yes, we did a lot of tests, maybe 20 tests to try to figure it out. What's the main reason of the performance?
Yeah.
What's the main reason of the output? Which technology will affect it?
That's crazy. That's insane. Thomas?
Yeah, it's crazy.
We're both geeks, so we're quite shocked right now, to be honest.
I told it before that I think we have a really efficient device here. And I'm shocked about the other device. I don't know what it is, but
yeah, it didn't perform well.
It's crazy. I mean, I know it's it's up down to the board and the wiring inside the mod, and you have to make a good job on the device that it works well. And I know there's a lot of devices that are not so well made out there. So I had seen devices with DNA chip, they don't work well because the wiring was crap.
Yeah, it's not just the chipset, it's the whole build quality
thing
of the
on
thing.
the build quality, yes. And yeah, but how I said, it's crazy.
It's insane, the difference. But did you use proper batteries for this test? Yeah.
Yes, of course. Yeah.
Yeah.
We use the same battery.
Fresh,
good
batteries.
Good battery.
Okay.
And they are the same.
Yeah, but it's interesting that you use not only fresh, so you discharge battery to test it on this level. That's an interesting point, because I think nobody did this before.
I don't think so.
No,
I don't think so. And it's quite interesting because we always test the chipset.
Yeah, but
and look at the chipset.
this is how you vape over the day, because you start with a fresh battery in the morning, then lunchtime you have 50%. So and you expect a good vape, and that's what people want.
That's quite insane, actually. I will try to pay more attention to this in the future, anyway.
Feel it.
We're gonna discuss the future of vaping technologies. It's an open discussion, so and I can't wait to hear your answers about that. The main question is, it's 2030, yeah? What is the average vape looks like? John,
is there such a thing as an average vape? I think the one thing I love about the technology that we have is, if you look over the last 10 years, everybody asks me the question, well, where will vaping be in 5 years?
Yeah.
And the answer to that question is we don't know. Technology is advancing so fast and efficient. We've seen today that the build of these products, the efficiency of these products is just getting better and better each time. But I think where we need to look at now is, from an environmental standpoint, is the materials that we're making these devices out of, so that they last longer, that they're easily recyclable. Battery efficiency, like we just talked about, is really important, because these resources are getting more and more expensive. They're getting more and more scarce as we use them for electric cars, for instance, and other things, electric bikes. So we have to become more efficient, and I think our consumers are also demanding this as well. So this is very important for manufacturers to think about.
Poti?
No, well,
the average Geekvape vape in 10 years from now. What does it look like? Looks like a pod, looks like a massive box. What do you think?
Yeah, I would say nowadays I saw a lot of new things, a lot of new stuffs coming out every day, right? Such like low temperature heating, ceramic coil, and many others. I'm glad to say every brand is keeping innovative, and they also got some breakthrough in their own areas. But I would say the vaping is a comprehensive experience. It's just like a system. It has its own core, just like a smartphone, like CPU. So I would say in the future, maybe we can call it VPU, like vaping processing unit. It's a new concept. It means we cannot just focus on just one technology, but also it's a wide experience. It's wide technology. We need to integrate that and make it better performance. Use it in the best way. Provide the best performance. That's my point of view.
Okay.
VPU is future.
All right. So integrated systems.
Integrated system.
Yeah. Well, okay. All right. Thomas.
Yeah. I think,
what's your wild guess?
Yeah, I think the technology is getting better, so that's a good part of that. But I think vaping is changing right now, because we see all the new disposable users. So, and what we see is that people like it easy. So. And I don't know. I hope we see in 5 or 10 years maybe pod systems, very, very good pod systems. So think we don't see that much big clouds. Depend on taxes everywhere, and yeah, I think
because in Germany you already
it's
you already have the taxes.
it's crazy.
Kind of crazy.
You have to be rich to be a cloud chaser.
Yeah, exactly.
So yeah, I think I hope pod systems maybe is the future, or devices like this with less clouds. So for I mean, rich people can use can buy the low ohm coils. I think, but
I'm laughing, but it's not really funny. The whole tax in Germany is gonna make vaping extremely expensive.
Yeah, it's
so nicotine is gonna go up in the systems of everyone.
Every liquid.
It's
not depend on the nicotine. It's every part of the liquid. Water. Just you buy water in a vape shop, you have to pay tax on water. So that's crazy. You buy PG, you have to pay tax. You VG, you have to pay tax. Aroma, you have to pay tax. So everything. Yeah.
Yeah, everything that's vape related, basically.
Yeah. And when you buy it in a drugstore or something, or somewhere else, then and you mix all together at home, then you can get in jail. So, and I think the devices will be getting smaller, like pod systems like this, with better technology, smarter technology, maybe. So
maybe the super capacitor that we saw recently coming out. That could be a thing, with a super fast charging, for example.
Yes.
Like reducing the loading time, like back in the days with the internet and the games and all that. The loading time will now be super short. And that's what I envision for the future, at least.
Of course, faster charging is important.
And it's not about the device. I think a big part will be the juice. Yeah, because now we have the people, they say, oh, disposables, they taste so good, and they can't even get this taste out of a pod system. So I think companies, they make juice, so they have to change something. I think that's an important thing.
Yeah, also adapt the liquid to the hardware, which is why basically you were talking about considering the whole thing as a system.
I think that's really important because we've got to look at who our new consumers are, and they're those hardcore smokers that haven't made the switch to vape. They're the older demographic that maybe aren't as technology savvy. And we're finding this in the UK with disposables, is that they're a great way in to the segment because they're simple to use. So we've seen an 8% increase in users in the UK. It's gone from 4.6 million to 4.2 million over the last year, which is fantastic. But what we're finding then is they're not staying on the disposables long because they're expensive to use, and they're moving on. So we have to make that transition for them easy, and keep them simple. And that's why even devices like this have a simplicity mode built in. So it's thinking about that consumer in the future.
The simpler, the better.
The simpler, the better, I think, is the way to go.
I think the disposable, they learned the whole industry this, because we kept it complicated for a very long time, thinking it was simple for us. But then again, when you place yourself into the shoes of a smoker who just lights up the cigarette every day, then it's complicated. You have to take care of the juice, the resistance, the charging, the whatever, the chipset, the power.
Absolutely.
It's quite complicated.
And I think the other thing is, and you saw this with talking to people in the street earlier on, if they have a bad experience, they'll leave vaping. They'll go back to smoking. So it's really important that we give them that confidence and that ability to vape well.
Sure. Well, thank you guys for coming to the show. That was very pleasant. Thank you, Poti. Thank you, Thomas. Thank you, John.
No problem.
Thank you, guys.
And thank you for watching. We'll see you soon and have a good day. Bye-bye.